Hello, Dr. Maya Dunne here. I am explaining you the lab, the copy of surface tension and intermolecular forces. In this lab, will help you to understand the intermolecular forces and the relationship between the surface tension, which is one colligative property, and how surface tension relate with the intermolecular forces. You need to know what is surface tension, because of the surface tension you see the surface tension in day-to-day activities, every day. If you see the little bugs like insects walking on the water bodies, that's because of the surface tension. If you get a glass of cup of water, you put a little paper clip and you don't see, even though it's made out of metal, it's not gonna sink, it's gonna float. That's because of the surface tension. So what are these intermolecular forces? Intermolecular forces are attractions between molecules. That means how one water molecule attract with another water molecule. So that's what we are talking about today. And also in this lab, you will understand what is the how these surface station different from one molecule to the other one. At the very first, we compare the surface tension and the intermolecular forces of pentane and octane. For this lab, you don't have to have any prior intermolecular force knowledge. Um, so you need to know one thing, that is the when the uh, surface tension is higher, intermolecular forces also increase. So let's see what is pentane and octane. Pentane, it is pent. Pent is 5. N is alkane. So octane, octa is 8. So then in this, if you go down the lab, you see when you do the section, okay, this is pentane. You see the black ones are the carbons. So 1, 2, 3, 4, 5. You go to the octane. Go down the octane. Octane has 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons. So pentane and octane, the thing you need to know is octane has 8 carbons, pentane has 5 carbons. And they ask you to find the surface tension, or which has the highest intermolecular forces. You will see when you do the experiment the octane has higher. Why octane has higher intermolecular forces? Because octane is a bigger carbon chain, 8 carbons. So it has the longer area to interact with the other molecule. So it binds the other molecule much stronger. And then if I draw the pentane and octane for you, if I show you, let's see. So this is, you don't need to know drawing at this level, but if I show you the pentane, 1, 2, 3, 4, 5, and then you have hydrogens, H3. You, like I'm telling you again, you don't need to draw these things, but I'm just showing you. The only thing is, like, this is the 5 carbons. So then if I draw another carbon, 1, 2, 3, 4, 5, and then it interact like this, 1 carbon. Let's say drawing like that. So this is an interaction, right? And then if I draw the 8 carbon, 1, 2, 3, 4, 5, 6, 7, 8, longer, right? And then this is octane, and then another one, 1, 2, 3, 4, 5, 6, 7, 8. And you see, this has more places to interact. Another color, see, more places to interact. So it's more interaction. So it's higher intermolecular forces in the octane. So this is pentane and this is octane. So octane has higher on intermolecular interactions because of it has longer surface area. And also you see the pentane and octane, they have only carbon and hydrogen. We said this when the compound is a carbon and hydrogen, it doesn't have any like oxygen, sulfur. So these compounds we call non-polar compounds. Let me get another color. Non-polar. Okay, so when these kind of a compounds, they only have like we call the very weak interactions. We call because no oxygen. When a compound has oxygen or nitrogen, we call those are non-metals and little bit more electronegative. The electronegative means more electron pulling towards itself. So we call whenever there are oxygen or nitrogen or sulfur in the compound, we call they're more polar. But this compound is very blank, like only carbon and hydrogen. We call them as they're non-polar compounds. Non-polar compounds, weak interaction, we call London dispersion or Van der Waals, same name, okay? London dispersion, or we call dispersion, or we call Van der Waals. So all same thing, all same name. And then this is the pentane and octane. And then if I tell you, okay, so a compound with the oxygen come to the picture. What happen if a compound with oxygen come into the picture? Be like these. When you go down, you compare the bigger the carbon chain, the bigger the interaction. You go down, and when you go down, you will see, oh, there's another one. It comes a pentane, a pentanol. So the pentanol has oxygen in it. Whenever the oxygen comes, it has much stronger interactions because then it's dipole-dipole interaction. So the weakest forces within the nonpolar molecules, you can easily see when you go to the get the the gas to get the gas to a vehicle, you see the smell because and all the like a fuel we get to our vehicles, all the gas we get to our vehicles, they're non-polar, they are octanes like all the hydrocarbons. So why you get the smell? Because they have very weak interactions between themselves, so they are very volatile. But when you come to the pentanol, they have oxygen. It can be ethanol, it can be methanol, or it has oxygen. When there's oxygen in the compound, that is a little bit higher interaction than London dispersion forces, we call their dipole-dipole interactions. So dipole-dipole interactions are stronger than any of the Van der Waals. So Van der Waals forces, so when the oxygen comes, it gives the higher interactions um, than the dipole. So that's what this all the lab is about. And I hope this video help you to understand the theory behind it. Okay, thank you.